FastMCP 3 implements a server-level transform pipeline that modifies tool discovery and execution through composable middleware components. The CodeMode transform introduces an experimental abstraction layer that replaces direct tool exposure with meta tools for on-demand discovery and sandboxed execution, enabling dynamic workflow composition while maintaining the original tool implementations unchanged. We are about to examine the foundational setup, where a FastMCP server instance is configured with the CodeMode transform, establishing the discovery and execution infrastructure that will mediate all subsequent tool interactions. The initialization pattern demonstrates how transforms modify the component flow from providers to clients, with CodeMode specifically wrapping existing tools in a discovery-driven execution model. From FastMCP, import FastMCP. From FastMCP experimental transforms CodeMode, import CodeMode. MCP equals FastMCP server. Transforms equals CodeMode. This code demonstrates the basic setup of FastMCP with the experimental CodeMode transform. The pattern here is straightforward. We're creating a FastMCP server instance with a server-level transform that modifies how tools are exposed to clients. The CodeMode transform wraps existing tools in a code execution layer, replacing direct tool access with meta tools for discovery and execution. The mechanism works by intercepting tool discovery requests. Instead of seeing raw tools like add and multiply, clients interact with discovery tools like search and get schema, then execute workflows through a sandboxed execute tool. This three-stage approach balances token efficiency with flexibility, letting LLMs discover only what they need rather than flooding context with unused tool schemas. This setup is particularly useful when you want to expose tools to LLMs without overwhelming them with your entire catalog upfront. The trade-off is additional round trips for discovery, but this cost is often justified in complex systems where the alternative would be flooding the LLM with irrelevant tool details. The server identifier, server, appears in protocol handshakes, but doesn't affect functionality. It's purely for client-side identification during connection establishment. Let's break it down line by line. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, which serves as the base class for creating MCP model context protocol servers. This class provides the core functionality for server implementation, but doesn't show any specific configuration or operational behavior in this import statement alone. From FastMCP experimental transforms CodeMode, import CodeMode. Imports the CodeMode class from the FastMCP experimental transforms module, which provides functionality for modifying code-related components as they flow through the server's transform pipeline. MCP equals FastMCP server. Transforms equals CodeMode. Creates a FastMCP instance labeled server with a CodeMode transform applied. The transform will modify components as they flow through this server instance, acting as a filter in the pipeline between providers and clients. The server identifier appears in MCP protocol handshakes for client identification purposes. The CodeMode transform fundamentally alters how tools are exposed to clients by replacing direct access with a discovery-driven execution model. By wrapping the FastMCP server instance with CodeMode, you're inserting a middleware layer that intercepts tool discovery requests, exposing meta tools like search and get schema instead of raw tool implementations. This three-stage approach, discovery, schema retrieval, and sandboxed execution, optimizes token efficiency by letting LLMs dynamically explore only the tools they need, rather than flooding context with unused schemas. The trade-off is intentional. Additional round trips for discovery are justified in complex systems where the alternative would be overwhelming the LLM with irrelevant details. The server identifier, server, serves purely as a protocol handshake label, while the transform pipeline modifies the component flow from providers to clients, maintaining the original tool implementations unchanged beneath the abstraction layer. This pattern balances flexibility with efficiency, enabling dynamic workflow composition without sacrificing the underlying tool ecosystem.
The tool walks into the transform, but walks out as a namespace it never knew.